Hello everyone, myself Mrs. Archana Mhatre, lecturer in Electronics and Telecommunication Department. In this video, we are going to continue with the first unit of Basic Electronics, that is Semiconductor Diode. Semiconductor Diode, in this we will see the PN Junction Diode. It is not possible to manufacture any device using only a P-type or only a N-type semiconductor. The Pn junction is the basic building block on which the operation of all the semiconductor devices is dependent. When the p-type semiconductor is suitably joined to an n-type semiconductor under suitable conditions by using special technique to form a junction, the contact surface is known as a Pn junction. Now this is the diagram for formation of Pn junction. P-type semiconductor and N-type semiconductor are joined together with the help of a special fabrication technique to form a Pn junction. Terminals are brought out for the external connection with the P and N-type semiconductor. The P side is called as anode and N side is called as cathode. The N side consists of a large number of electrons and few thermally generated holes, whereas the P side consists of a large number of holes and few thermally generated electrons. Thus, the electrons are majority carriers and holes are minority carriers in the N region, whereas the roles are exactly opposite in the P region. The Pn junction forms the basic semiconductor device called as a diode. At the junction, one side has a high concentration of holes, whereas other side has high concentration of electrons. The free electrons from N side will diffuse into P side and recombine with the hole present there. Each electron diffusing into the P side will leave behind a positive immobile ion on the N side as shown in figure. Due to this recombination process, a large number of positive ions accumulate near the junction on the N side and large number of negative immobile ions will accumulate near the junction on the P side. The negatively charged ions on the P side will start repelling the electrons which attempts to diffuse into the P side, and after some time the diffusion will stop completely. At this point the junction is said to have attained an equilibrium condition. Now, formation of depletion region. The shaded region on both sides of the junction in figure contains only immobile ions and no free charge carriers such as electrons or holes. In other words, this region is depleted of the free charge carriers. Therefore, this region is called as depletion region. Practically, the width of the depletion region is 0.5 to 1 micrometer. It is very small as compared to the P and N region. Now, barrier potential or junction potential. Now, here in this diagram you can see this is the N region, this is the P region. Now, here it is the depletion region formed between the junction of N and P-type material. So this is a depletion layer, and when we measure the voltage at this depletion layer, that voltage is called as a barrier potential or junction potential voltage. So due to the presence of immobile positive and negative ions on opposite side of the junction, an electric field is created across the junction. This electric field is called as a barrier potential or junction potential. The polarities of barrier potential are decided by the type of immobile ions present on the two sides of the junction. Thus, the negative terminal of the barrier potential is on the P side and positive side is on the N side, as shown in the figure. This is called as a barrier potential because it acts as a barrier to oppose the flow of electrons and holes across the junction. The barrier potential measures in volts. The barrier potential of silicon material is 0.6 volt and the barrier potential for germanium material is 0.2 volt. Thank you.